Hi there, welcome back to the third class to differential equation. We are looking at the study of what's it called there, direct integration method. So last class we list out the example what we're discussing in today's class. So let's start with example one. Let's start with example 1 and 2, 3, 4, 5, 6, 7, and 9, 10. I will give assignments, right? So, but before then, let's proceed. Let's solve number 1 and 2 for this class. Next class, look at 3 and etc. Right? So let's number 1 and 2. So let's number 1 and 2. Take this off. Alright. Let's start with example 1. Number 1 says evaluate this differential equation. Number 1. So solution. Number 1 says I have dy over dx as being equal to 5. Please, first things first, whenever you have any question under the differential equation, ask yourself which method will work for this. In this case here, I just said earlier that when it comes to direct integration method, that you will always have dy over dx being equal to something in terms of x. Of course, here I have dy over dx equal to something. There's no x here, but I can still express 5 in terms of x. How? This is what? 5x to the power 0. Yes, this is still correct with this. X to the power 0 is 1. 1 times 5 gives you 5. So this is what? This is a problem under what? Direct integration method. This is how you identify them. How do you spot out this method? Check. You'll be having dy over the x equal to something in terms of x. This 5, there was no x here, but I can still express 5 in terms of x. How? I just showed you this stuff. Right? So these two are still the same thing. Let's solve this, please. What do you do first? Your first task is take the x. Take this the x, other side here. That gives you dy equal to 5 dx. Now we said, so take the x other side there. I have this here. Your next task says what? Integrate through. So integrating through. Integrating through. That gives you the integral of dy is equal to the integral of 5 dx. I have this, please. All right. I have this, please. Proceeding from here. What do we know? If I integrate the y, I will have y. We know that, right? So that gives you y equal to, if I integrate 5 dx, what do we know? We said first is first, bring a constant term after integral sign. So it gives you 5 integral of what? Dx. This one gives you that y is now equal to 5 into, if I integrate the x, of course I will have what? X. Next up plus what? Plus c. From here, this becomes y equal to what? 5x plus c. 5x plus c. This man, so this is the required solution of this differential equation. So this becomes the required solution to this differential equation question. So this is how I solve problem when it comes to the direct integration method using the concept of solution of a differential equation. Hi there, are you a candidate for the upcoming 26 JAM/WAEC examination? If yes, then I want to invite you to my JAM and WAEC tutorial class. In this JAM and WAEC tutorial class, we'll be looking at several topics such as mathematics, chemistry, and physics. For each of these topics, we'll be doing an in-depth teaching as well as solving past questions for the last 10 years for each of the topics. If this interests you, do well to click on the link you will see in the video description, or you can message me up through my WhatsApp number as displayed in front of you. See you guys in the next class, and welcome to Excellent Link Academy. Let's solve number 2, please. Let's solve number 2. Let's solve number 2. All right. Number 2, I have number 2. It was the y over the x, the y over the x equal to cos into 2x plus 7. All right. So let me take this number 3 off and number 4 off. So we can solve that question. All right. So let's solve question number 2. What do you do in this case? We said it's easy. This man is a problem under direct integral method. Yes. Now, what do you do first? You said what? Take the x other side here. That gives you, I'll have the y left. So the y is equal to cos 2x plus 7. So take the x here. That gives you, put this in a bracket, in a square bracket, and I have what? The x here. No problem. Your next priority is what? Integrating through. All right. Integrating through. So I want to integrate through. What do you do? That gives you the integral of the y is equal to the integral. Open your bracket. I have cos 2x plus 7 of cos dx. Please, how will you integrate this? What method of integration will you apply here? You know, when it comes to integration, there are 3 methods there. General method, we have the substitution method, we have the integrating by partial fraction. In this case here, what method will you apply? What method will work here? So think a little bit. What method will you think will work here? I've said you should go and watch video on integration. I've said that. I have the playlist on my channel. I'll also leave the link to the full tutorial video on integration. I'll leave the link on my channel. So for this one here, how do you solve this one? How do you integrate this? So what we know, if I integrate the y, of course, this one gives you y. Quick one is equal to, for something of this nature, what do you do? Expand first. Use integral to expand cos 2x first and attach the x to it. So I'm saying is pick out integral, pick out cos 2x, then attach what? The x to it. Done. This plus becomes plus. This same integral again. I have 7, then attach what? The x to it. This is how I solve this. This is how I solve this, please. Right? From here, what next from here? From here, listen, please. From here, if I integrate cos 2x with respect to the x, please, what method will I apply in this case? Check, please. If I have integral of cos 2x, I want to integrate integral of cos 2x dx. What method will I apply here? You can see that you need to know integration before you even say you're dreaming of differential equation. So go and build your foundation. This thing has been done so far. We have done all these videos on integration very well. Last classes. Go and check them back. Don't just learn and forget. You need these stuffs. From here now, what method do you apply in this case? In this case here, what method do you apply? Now, hold on a bit. Check what I want to do. Check what I want to do. Just watch this, please. Watch this, please. I'm going to pick out that question and solve on its own. Look up. If I have this one, I have the integral of cos 2x with the x. Let's assume this is my question, original question given. What do you do here in this case? How do you integrate this? Now listen, your first task is to let u to be equal to what there? 2x. Differentiate u with respect to x. I'll have the u over the x being equal to If I differentiate 2x, I'll have 2 as my answer. That's differentiation. So it gives you 2. From here, make the x subject. I want to make the x subject. Just what? Just swap. If I swap position, I'll have that the x is equal to what there? Du over 2. Of course, if I put 2 here, I'll be having du over 2 as this. This is the x will now come here. This is the x here. I'm having this place. At this point here, I'll say substituting. If you are familiar with integration, all this should not be a problem. You should know this. All right. For me, this gives you the integral of cos. That gives you cos into, you said 2x is now u. So I have u here. Dot, the x is what? The x is now what? Du over 2. I have this. From here, this gives you just only this one alone that is long like this. So just only this. Just watch. From here, this gives you the integral of cos u dot 1 over 2 dot du. Please observe. 1 over 2 is not magic. Please. It was this 2. If I shift this 2 like this, if I shift it like this and take this s back, it will be 1 over 2 that will be left there. So 1 times du gives you du over this 2. That's all. Not magic, please. Just shift this 2 to the front, the s to the back. You have something of this nature. From here, I want to integrate this. First, that gives you the integral of 1 over 2 should come out first, then cos u with respect to du. To integrate this, I have to bring out this constant term outside. That gives you 1 over 2 integral of what? Cos u dot du. Please, if I integrate cos u, what will I have as answer? Come back. Let me take you back to differentiation. If I have that y is equal to sine x. If I differentiate this one, the y over the x is what? Is cos x. Given that y is equal to cos x, the y over the x here is what? Minus sine x. This is differentiation. If I have x sine x, differentiate, I will have what? Cos x. If I have cos x, differentiate, I will have what there? Minus sine x as the values. What of integration? If I integrate, let's say if I integrate sine x, what's my answer? If I integrate cos x, what's my answer? That's it. Listen, we said integration is the reverse of differentiation. So if sine differentiation is giving you cos, what will be the reverse? Sine will give you what? So here's like that. If I integrate sine x, if I integrate sine x, I'll have what there? I'll have minus cos x. It was sine x give you cos x, but it gives you what? The reverse, which is what? Minus cos x. If I differentiate cos x, it gives me negative sine x. You've gone with the sine x. By the way, cos x, I have what there? Sine x. See, it's like the opposite, the reverse of this. So this and this, take the reverse. This plus cos x. Reverse gives you what? Minus cos x. This minus sine x. Reverse gives you what? Sine x. So here's the idea. If I integrate sine x, I'll have what? Minus cos x. If I integrate cos x, I'll have what there? Sine x. Please take note of this. Similarly, I'm assuming this u to be x now. If I integrate cos u, that gives you if I integrate cos u, that gives what there? Sine u. That gives you 1 over 2 into integrate cos u. That gives you sine u. Then next one plus c. I have plus c. That gives you plus c. All right, take this one off. From here, it gives you 1 times sine u gives you sine u over 2 plus c. Now, what's u? So u is what? 2x. So my final answer, if I integrate this top here, my final answer becomes sine u is what? 2x. So sine 2x over 2. Then top plus c. So integrating this, if I integrate cos 2x now, what's my answer? My answer is what? Sine 2x over 2. So I'll plug in this value, this answer inside this place. That gives you y equal to, if I integrate cos 2x with respect to the x, that gives you sine 2x over 2 as shown here. Next up, plus, if I integrate 7 dx, we said 7 should come outside. So I have 7 integral of what? Dx. From here, I'll have that y is equal to what there? Sine 2x over 2 plus 7 into, if I integrate the x, I'll have x. That gives you x plus c. This is our final answer. So this is the required solution for this differential equation. This is how you solve this particular question. Let's do example 3 in our next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright, guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, WAEC/JAM student, WAEC/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.